here we have a car turning a corner. The mass of the car is 1100 kilograms, and the speed around the corner is 22 meters per second. We know that the curve of the road here has a radius of 85 meters. So let's start off by drawing the free body diagram for the car, because that will help us inevitably solve the problem. So we have our car here, which I'll just draw as a point. We have some sort of frictional force, Ff. We know that we have Fg going down and Fn going up. We also need to know that Ff is the force of static friction, and in this case, it's going to be equal to what we'll call Fc, which is the friction of the centripetal force. Sorry. So we're going to say that Ff, force of friction, is equal to the centripetal force. So let's determine the magnitude of the force that that must be exerted to keep the car from skidding. So how do we ensure that the car doesn't kind of tail off and fly off? Because remember that centripetal force is an outward pushing force. So what do we know to solve for B? We know that the mass is 1100 kilograms. The velocity of our car is constant, so it's 22 meters per second, and we have a radius of 85. We're here looking for Ff. So this is going to be a value in newtons. So to solve this, we're going to make use of the equation that the centripetal force, in this case, which is equal to the force of friction, and it's actually not a vector because there is no direction in the question. So we have mv squared over r. So that is 1100 kilograms times 22 meters per second squared divided by the radius, 85 meters. This leaves us with 6,263.5 newtons. If we go to two significant figures, the force required to keep the car on the road, 6.3 times 10 to the 3 newtons. Now, how about determining the minimum coefficient of friction needed to keep the car on the road? So let's recall that our Fn, or our Ff, sorry, the force of friction is equal to our coefficient of friction times Fn. We know Ff, and we can solve for Fn. So we're going to start by doing that. Fn is equal to mg, which is the mass of the car, times 9.8 newtons per kilogram, 10,780 newtons. Now we can plug in and solve for mu, which is Ff over Fn, 6,263.5 newtons from the previous question, 10,780 newtons from this question, leaves us with a mu of 0.58, and there are no units there because the ends cancel, so therefore the minimum coefficient of friction needed is mu is equal to 0.58.